Okay, so today we will be talking about the chapter on atomic structure and ionic bonding and covalent bonding. So before I go into talking about the atomic structure itself, you must first understand the fundamental three uh, category. I call it category in chemistry. They are first element, which is what you can find in your periodic table, and next we have compound. A compound is basically two or more substances that are chemically combined. As a result, you can only separate them by chemical means. Such examples are water, which is H2O, table salt, NaCl, zinc chloride. So as long as you see as a chemical formula uh, in terms of ionic formula or covalent formula, then it's considered a compound, because the only way you can actually separate the elements itself is through chemical means or electrolysis. Then next I'll talk about mixture. Mixture are generally two or more that is mixed together physically, and as a result you only can separate by physical method, as it suggests. And some of the examples are soil, air because air is made up of oxygen, carbon dioxide, nitrogen gas, a lot of different compounds. So it's actually a mixture of compounds, that's what I call it. Next we will look into the elements. So as this is what you usually find in your periodic table, with a number 7 and 3, 7 on top and 3 at the bottom, with the element in the center. The 3 actually represents the proton number. Proton number has a charge of plus, and it symbolizes it with a P, and it has a relative mass of 1. What does relative mass means? Relative mass means that if I 10 kg and Xiaoming, for example, is 5 kg, so his relative mass is 1 to me is 2, so it's 1:2 ratio. As a result, his relative mass is 1. So this is what relative mass means in reference of something. Then next we'll look at the number 7. The 7 actually represents nucleon number. Nucleon number, what it meant is that it's the number of protons plus the number of neutrons. Neutrons has a charge of 0, it's neutral, and you can represent it with N, and it's a mass of 1, relative mass of 1. And next thing you need to know is that the number of protons is usually equal to the number of electrons for the element itself. So if proton has 3, electron will have 3, proton has 1, electron have 1. And the next type of category you need to know is called isotopes. Isotopes has a very unique definition. It's very easy to remember. The keywords are underlined here. Isotopes are same element. Remember, it must be the same element, same proton, and almost everything is the same chemical property. However, there's a slight difference in physical property, but different number of neutrons. So for example, this is an isotope. You can see the nucleon number is actually different, but the proton still remain the same. So as a result, this one will have a neutron of neutron of 4, and this will have a neutron of 3. And due to the isotope, you can actually observe something very interesting. Chlorine has a nucleon number of 35.5. This is because there's a certain percentage of isotope of chlorine 36 and chlorine 35 that resulted in the average to be 35.5 on Earth. So next, we will look into the atomic structure itself. So let's look at lithium, for example. Lithium has an electron or proton number of 3, which you can find on the periodic table. So from this information, what you can deduce is that you can actually deduce the electrical configuration. That means how will you expect the electrons to arrange itself in the element itself. So always remember, all these are electrons. The protons and neutrons are in the center of this. So let's take a look. So you have 3, then the configuration will be 2.1. Remember, the first shell of here can only hold up to maximum 2. So if you have 3, you have to fill up 2 first, and you're left with 1 to put it on the second shell. And the second shell can hold up electron of 8. Third shell can hold up electron of 18. Oh wait, sorry. For secondary school syllabus, you only need to know that the third shell, fourth shell, fifth shell, and subsequently only can hold up to electron of 8. If you are keen to find out more, you can do some Google research. But if you think about this, bromine, if you look at our periodic table, it has a proton number of 35. If it's 35, by right it should be 2.8.8.7, but you add up to be 33, so it's wrong. This is because the third shell can hold up to 18, so it's 2.8.18.7. Then you will get 35. And next, also, once you know this, you need to know that the outermost shell, the electron at the outermost shell, is what we call it as valence electron. And something for you to think about, electron actually exists as negative charge. So how is it possible that you can actually draw two electrons next to each other? It doesn't really make much sense because electrons will actually repel each other. So this is just something food for thought. You can think about it, but it's not in the syllabus for you to know. Okay, next we will look into ions. So how does an element becomes an ion? An element becomes an ion either when they lose electron or they gain electron. So for example, for lithium has an electrical configuration of 2.1, so it's not stable because there's one electron at the outermost shell. So how can we make it stable? You actually lose this electron. Once you lose this electron, lithium will gain a charge of plus, and as a result of that, you will become an ion. You will become a positive ion. And all metals will give a positive ion, while non-metals will result in a negative ion. And also, these are some of the common questions that you expect to see in the exam, whereby they tell you, maybe they can cover this and they give you this configuration. So do not be shocked that if the proton number is not the same as the electron, this could only mean one thing. It means that this must be an ion. Okay, so now let's move on into ionic bonding. So for ionic bonding, the key here is that you must know that ionic bonding is a bonding between non-metal and metal. If you cannot get this familiarized, you will have a difficult time doing ionic bonding. Ionic bonding is a marriage between non-metal and metal. It's like a girl and guy. So let me give you an example. Let's look at sodium chloride, for example. Sodium chloride. Sodium has an electrical configuration of 2.8, while chloride or chlorine, if you see in periodic table, has an electrical configuration of 2.8.7. So this is how you actually draw out their atomic structure. And from here you observe that in order for this to be stable, you have to give away one. So for this to be stable, you have to take in one. So isn't it such a coincidence that you can actually transfer one electron? So this is what we call transferring of electron from the metal to the non-metal. Hence, the metal will achieve a stable configuration of 2.8, while the non-metal will also achieve a stable configuration of 2.8.8. And do bear in mind that right now what I'm using is dot and cross diagram to actually to indicate such atomic structure. This is because that if you use both cross, it's hard for you to actually for examiners to see which is which, and you cannot differentiate the electrons. So please bear that in mind, and also during your working, please put legend. So let's look at another example. For example, magnesium chloride. Magnesium is in group 2, so it has an electrical configuration of 2.8.2, while chlorine has 2.8.7. So what happens is that you will end up drawing something like this, because one magnesium has to give out 2, but one chlorine can only take in 1. So you look at here, how many chlorine do we have? We have 2 chlorine. So you draw 2 chlorine, each of them will receive 1 electron from this magnesium. So this is your final answer. You can either draw it like that, or what you can do is that you can draw one of them and you put a 2 in front, depending on your school's preference. But I highly recommend you doing this because it saves a lot of time. And next, I will teach you guys how to actually tell the charge and to actually name the formula itself. So for example, if it's magnesium chloride, you look at magnesium and you tell yourself, how many electrons must I lose to be stable? I need to lose 2. So if I need to lose 2, it must have a charge of 2 plus. Then chlorine, how many do I need to gain? I need to gain 1. So I will have a charge of 1 minus. So you write out this working and you do a cross multiply, you will expect to get MgCl2. And this is how you derive the formula. This is the cross multiply method. However, there's a few charge that is not, there's few compounds, or there's a few ions that charge is not given in your periodic table, which you can't find, which you have to memorize by heart. But I believe through practice, you can actually familiarize yourself with all of this. So some of them are the most common ones are carbonate, which is CO3 2 minus, sulfate SO4 2 minus, nitrate NO3 minus, ammonium NH4 plus, zinc, which is a transition metal, lead transition metal, silver transition metal, copper transition metal. Transition metal means that it can exist in different charge state. However, these are the most common charge that they exist in for your secondary school syllabus. Covalent bonding. So covalent bonding is a marriage between non-metal and non-metal, but for ionic is between metal and metal. So let's look at the first example that we have here. It's called chlorine gas, Cl2. Chlorine gas is in group 7 and all of them exist as diatomic. That means they exist as Cl2, F2, I2. So let's look at chlorine gas. Oh, sorry, I made a mistake here. It should be Cl. Okay. So let's look at chlorine gas. How you do this is that actually you draw out them in terms of this dot format. Of course, I didn't draw everything because right now you can actually draw it as its outermost shell, because most of the questions, if they didn't state it's fine for you to actually just draw the outermost shell. So for chlorine outermost shell, you expect to have 7. So you have 7 electron here, 7 electron here. So how to make them stable? Since ionic bonding is about transferring of electron, covalent bonding is about the sharing. So you want to share things together. So how do you share? You actually make a bond between, just like a line, and you share one pair. This is considered one pair. So this Cl will take 1 out and this Cl will take 1 electron, and they will make a sharing pair together here. So from here you can actually derive into this stage whereby you actually draw it in terms of a dot and cross, and you can actually see in the center there's a sharing pair of electrons between the chlorine gas. And next we'll look at oxygen gas. Oxygen gas is the same diagram here, but you realize that if you only share one pair, it's not going to be enough, because how do we know? If let's say you only share one pair and I cover, you realize that there will not be 8 electrons here, and if you cover here, you won't be 8 electrons. While for this case in the chlorine, if after I share, I cover here, I should have 8 electrons. I cover here, I should have 8 electrons. So for this case, you need to share 2 times. So you will have 2 dot and cross pairs that share together, and this is your final answer, and this is how you should draw it out to be like. And for a more complicated one, such as carbon dioxide, you realize that carbon will actually need 4 electrons to be stable. So you will actually expect it to have 4 lines. While oxygen needs 2 electrons, so you will expect it to have 2 lines. So as you can see, oxygen has its 2 lines, and carbon has its 4 lines. And as a result, once you transfer over, you look something like this, and this will be a stable structure. So hopefully you can understand more, and stay tuned. Thank you.